and today I'll be showing the effects of gravity and drag forces on falling objects. And the first object I have here is a miniature basketball. Its mass is 0.07 kilograms and its length is 0.0635 meters, which is shown right here. I'm going to go ahead and run the video. And as you can see, as time progresses, the distance between the positions change, which shows the acceleration of the ball. And if we go to Python, I have it set up with no drag force, and we're going to run this. And as you can see, there's no arrow pointing up, which would signify drag force, and it has a nice curve, which means that it continues to accelerate as time progresses. And if we show this with no drag force, here's the Python model, here's the tracker model, and here are the two together. As you can see, there is some type of drag force acting on the ball, and without the presence of drag force, there's a complete difference between the tracker model and the Python model. And if we want to see with drag force, which I calculated to be at 0.189, well, the B is equal to 0.189, excuse me. We can see here in the tracker model and the Python model that they are a little bit more closer in their values. Move this up. They are a little bit more closer. There's not too much of a gap between the tracker model and the Python model. Now if we go to my other object, which is a styrofoam plate, unlike the ball, the positions between each position, the distance between the positions is very close, almost the same, which kind of signifies that the plate is almost moving at a constant velocity as it goes to the ground, which shows that there is a drag force, a large drag force acting on it. Well, not necessarily large, but there is a drag force that is causing it to move at a constant velocity. And if we go to our graphs, we can see the difference between them. One is a little bit more linear and the other one is curved, and we can see the difference between them. Now if we go to graphs with drag force, which I calculated to be at 0.09, as you can see right here, you can see that both graphs line up a little bit better and that they're both a little bit more linear. So without drag force, the slow moving object, the plate, will continue to accelerate at a higher rate. Of course, it will accelerate with drag, but its acceleration is so small it almost moves at a constant velocity. And if the plate was thrown downward, the end result would be very similar due to the plate's large surface area and light mass. Drag force would still become equal and opposite of the force of gravity. So thank you for listening. I hope you learned something from this demonstration and this computer model. Hopefully, if you did learn something, you can apply it to everyday life maybe, or go out and show your friends something cool. Thank you.